So today we're going to be using this car, a 1994 Tercel. It is fuel injected. We're going to be testing the emissions that come out of the tailpipe, and we'll be capturing them with this brand new sock. Right now it's totally factory stock. It has all the parts that it should. It passes all federal emissions, all that good stuff. So we're going to put it on for 20 seconds at idle, and then we're going to increase the engine speed for 20 seconds.
Put the sock inside out right now.
See what kind of junk came out. So it looks pretty clean because the cat is doing its job. There's no unburned fuel really.
There's very little stuff there, but overall it does a good job.
And the good thing is the toxic gases that are emitted are made so that they're harmless, which they're odorless and colorless.
So Matthew has just disconnected the catalytic converter from the car. So now we run the experiment again, we will hopefully get different results. And what do you think that will be?
Well, I think that the sock will be kind of drenched in some unburned fuel. It'll smell really bad. It'll be really full of soot, and it'll be just generally dirty. Because
the converter won't be there to do its job. It won't be there to filter it out as well.
This is all the really harmful stuff that would normally be going into our environment, if not on the exhaust system.
So basically, as you can see, it got a lot dirty, proving the fact that with the catalyst converter disconnected, the results are completely different. Just as you hypothesized, right?
Yeah. And this is the part where it kind of collected, and then it kind of expanded the sock like a balloon, and it's like secondary collection, but that's a lot worse. I definitely wouldn't want to breathe that. So this is part 2 of the catalyst test. We are going to do the same thing as part 1. We're going to use a sock to find the emissions of the average automobile exhaust system, and then we'll take off the catalytic converter and see what kind of differences that'll make. Again, we expect it to have maybe unburnt fuel. The sock might feel wet, might smell like gasoline. The exhaust in general will smell a lot worse, and it won't be as hot. So that's what we're expecting. Alright, so we just took off the catalytic converter. So this is just a conclusion to our experiment that we did with catalytic converters, how exhaust emissions change with them being in use and them not being in use. We just did a conclusion just to summarize the results, talk about error, human error, other things, what could have gone better, and just to give you some illustrations. This is a basic picture of a catalytic converter, and we'll put this on the screen for you, but basically harmful things like hydrocarbons, carbon monoxide, and NOx emissions go in, and water vapor, carbon dioxide, and just plain old nitrogen comes out. So these are pretty inert. There's a catalyst substrate here that the reaction energy is lowered with, and what makes these kind of special is the rare earth metals that are in them. And it could be platinum, palladium, or rhodium, which makes these kind of valuable, maybe possibly for theft. And this is just the balanced equations, and we'll put that on the screen. The next illustration here is the motorcycle that we used. This is an illustration of the exhaust system. It's a 1992 Honda Nighthawk, or a CB750. It's got an exhaust manifold here with 4 exhaust ports, and 2 of them split into one pipe and 2 of them split into another pipe, and it's basically just plumbing for the air. There's not much going on here. There's no O2 sensors, there's no catalytic converters, and it just kind of has mufflers. This is a carbureted engine, which might be why, and we'll put that on the screen too. And this is the first car that we used. It's a 1994 Toyota Tercel, and it's a little bit different. It's also an inline 4 engine, but all 4 pipes come together to make one pipe that loops under There's the cat. There's a resonator for exhaust quieting. There's a muffler and emissions come out the back. We unbolted it right there to do some testing. This is a fuel injected engine. There's that. And this is the other vehicle we used. It's a 1994 Nissan pickup truck. This is a little bit different. It has a V6 engine, which means it has 2 banks of exhaust ports, 3 on each side, and they come together at the Y pipe. Some couplings. There's a catalytic converter. What's different about this one is it has an O2 sensor to measure the exhaust that's coming out to see how it should make the air-fuel mixture lean or rich. And then you have a muffler and emissions. We unbolted it right there, and this one's also fuel injected. And some of the results we have, this is the motorcycle sock. Not much really happened here. You can see some dirt there, but that's only where it contacted the exhaust. That's not really from the exhaust. Pretty clean. Smells like carbon, really. This is the next one. This is the truck with the cat on. This one's a little bit dirtier. Again, that's just where we put it over the exhaust. Pretty clean. Smells like carbon. This is the Toyota car, the cat. Again, just kind of carbon buildup on the tip of the exhaust that rubbed off. Pretty clean. Smells the same. And here's where it gets interesting. This is without the catalytic converter, and it's pretty dirty. Just you might not be able to see it in detail, but it's just generally brown. There's a lot of buildup here where it kind of like fell over like that. Just generally dirty. And then this is the truck, and this is pretty bad. I'm glad I have a cat on my truck. That's kind of dirty. Wouldn't want to breathe that. And kind of smells like fuel, as with this one. Alright, so this is some data that we wanted to collect about these socks. We're going to try and burn them to see how much unburned fuel or hydrocarbons are really being collected on these. This is a sock we didn't use. This is a control sock.